depending on the thickness of the R value, and is only the timeline that it takes for it to transfer through. But what they don't tell you is, once the transfer confers, then you have conduction. Then 90% of all the heat that comes in contact with the top just transfers right through. And I want to just show you so that you can get a grasp of what this material is. And basically what we have here is, if you've seen in all of his literature, is a material that reflects heat at a rate of 97% on both sides. There's only one other material that reflects heat greater than that, and this is pure aluminum that's polished, and the only thing it reflects greater is pure gold. And if you notice our satellites and when they landed the lunar module on the moon, all the electronics and everything were wrapped in gold foil. And that, you know, since NASA had the budgets that they did and they were forced to do this thing and get them on the moon, they didn't take any chances on anything. And that was the reason for the gold foil. Now, I need a volunteer here. All right. Now, if you would, hold your hand out. This isn't going to hurt too bad, okay?
Promise?
Yep. Tell me when it gets hot. Now, you don't have to go so bad that I burn your hand, okay?
Yeah, completely cool.
I can reflect it on your face. You can feel the heat on your face.
Yeah.
But you stop the transference of heat.
That's right. Yeah.
Here, let me warm you up a little bit. You can still feel it. The heat source is there. Yeah, but what you're doing is you're directionally controlling heat flow. You just stop it. Now I can reflect it on you. So what we're going to do here is just a little demonstration today. What this little demonstration is going to illustrate is exactly what we talked about earlier about how the heat transfers through. And in this particular case, I'm using insulation that has, over a period of time, and this is what happens when insulation heats up and it takes on a little moisture and then dries out, it compacts itself. So over a period of time, this is how it's all, you know, pressed down. So this started out as 4 inches thick, and now we're about 2.5. And if you would plug her in again. And if you would read the temperatures on the front for me.
This one is about 76. That one's about 80, 90, 92, 94, climbing.
So it's already climbing. So it doesn't take long for a lot of heat to start to transfer through. Think of insulation, and this is just a real simple analogy that I use. Think of insulation like a sponge. You take a sponge and you put it under a sink of dripping water. When that sponge fills up, what happens? Heat follows the same path of resistance. So, you know, once it goes through, you virtually have nothing. Now, all these insulations, you know, no matter whether it's a foam or whatever, that's the R value number once it comes through. Once that has occurred, you virtually have nothing, okay? What this does is changes the whole thing. And this whole program came about through an engineer that basically sponsored me in a program in Texas to take existing technology that we have and convert it into civilian applications. And he told me, he said, I never have understood why we don't use this in housing, you know, with the current rise of utilities. They're never going to go down. You don't ever see utility bills or rates go down. They're always coming up. Why we don't take advantage of this? So we started out in our career, and when we first did this material, we put it on craft paper, and that was just a big mess. And now we marry it up to this mat here that gives it the strength on the inside. Now, can you see the number here?
It's right through the roof, yeah.
Okay, so we're already over 220 degrees Fahrenheit, okay? And what's the number on this side over here?
Probably 78. Like, oh, I guess. The rubber glasses. Yeah, AB2 or something.
Okay. Now this is an extreme test, but here is the crux of the whole thing.
That's cool.
Does that feel like 200 degrees?
You're breaking conduction. Is that it?
You're reflecting it. You're breaking it.
You're breaking the conduction
Right.
process.
You stop the transfer.